Good afternoon. Today we're going to solve quadratic equations by graphing. Tomorrow we'll solve them by factoring, and then the day after that we'll solve it by taking the square root. So there's lots of different methods to solve a quadratic equation. There's actually 5 different ones. So we'll be taking a look at each one over the course of the next several days. Just a little recap from what we did yesterday. So we started taking a look at quadratics. When you graph them, it makes a U shape. The axis of symmetry is a vertical line that cuts it in half. And then we went through and we learned how to put equations in vertex form. So today we're going to do some more things. We're going to start with graphing, and we're going to be using Desmos to help us find our answer. So let's jump into it. So the first one, the roots of the equation and the zeros of the graph are the same. They are also called the solutions, and there's no spot for that, but I'm just going to put in quotation marks here that these are also called the solutions. Okay. So the roots of the equation, the zeros of the graph, the solutions, all 3 words are synonyms. They mean the same thing. So a quadratic equation can have 0, 1, or 2 real solutions. So a quadratic equation can have 0, 1, or 2 real solutions. So these are the options for a quadratic. And keep in mind, reminder, quadratic has to have something that's x squared in it. If the solution has no real zeros, it has 2 imaginary solutions. We can use several terms to represent the solution. So we're just going to rewrite them again. So that's what I was saying up here. We have lots of different ways to say find the solution. We can use the word roots. We can use the words zeros. We can use the words x-intercept. Or we can use the word solutions. So all 4 of these words are synonyms. One problem might say find the roots. Another problem might say find the zeros. Another problem might say find the x-intercepts. Another problem might say find the solutions. They all mean the same thing. So over the course of the next few days, I'll be showing you several ways to find the solutions. And today's way we're going to focus on graphing. If you're going to solve a quadratic equation by graphing, you're looking for where it crosses the x-axis. So we're moving on to the first method. It tells us to solve each quadratic equation by graphing. Your solution, so you want to star this, highlight this somewhere in your notes. Your solution is where the graph crosses the x-axis. So highlight that, star it, underline it, bold it, all that good stuff. So today we're going to be solving an equation by graphing it. When you graph it, your solution is where the graph crosses the x-axis. So we're going to go through these 5 examples that I have down here. We're going to graph it in Desmos and see where it crosses the x-axis. Those 2 points, possibly 2 points, it could be not at all 1 or 2. So wherever it crosses is going to be our solution. Now, if you're going to solve an equation by graphing, you have to make sure it is set equal to 0. So if you're going to solve an equation by graphing, we got to make sure it's set equal to 0. So this first problem here is already set equal to 0. So we don't have to do anything but graph it in Desmos. So it already has equal 0 here, so we are good to go. So I'm going to go through all 5 problems first, make sure they equal 0, and then I'll graph it in Desmos. So this one's already done for us. So we just need to graph x squared plus 8x plus 12. All right, number 2 is not equal to 0. So we're going to have to do maybe 1 or 2 steps depending on the problem so that we set it equal to 0. This is a minus 21. I need to move it over to the other side so that my problem equals 0 like problem number 1. So we need to add 21 to both sides and add 21 to this side. These are not like terms. 1 is an x squared. 1 is an x. 1 is a number. None of those can go together. So we just write it out. Negative x squared plus 4x plus 21 equals 0. Now the problem is in the right form that we need, and in just a couple of minutes we'll go in Desmos and we'll graph negative x squared plus 4x plus 21. All right, let's look at number 3. Number 3 is already equal to 0, so we don't have to do any work to it. So we'll just leave it be for a minute until we graph it. So we're going to be graphing that. Jumping down here to number 4, we have negative 2x squared minus 5x equals negative 1. Clearly, this is not equal to 0, so we need to add 1 to both sides. So add 1, add 1. Again, like terms. This may be the only thing that gets you with this method. These are not like terms. This is squared, this is to the first power, and this is a number. So we're going to write everything out separately. So notice I didn't combine anything because I don't have any like terms to combine. I just wrote everything out separately. And we'll graph this in Desmos in just a minute. And the last one, let's make sure this is set up in the right form. 3x squared equals 9x plus 1. Now we have some options here. You can subtract 3x squared from both sides and move it over here to the right side. Generally, however, we move everything over to the left side so that equals 0 is on the right side. So I am going to subtract 9x from both sides and subtract 1 from both sides so that it's equal to 0. So I'm going to subtract 9x and subtract 1. So subtract 9x and subtract 1. So I'm going to subtract it on this side and then subtract it on this side. None of these are like terms. So I'm going to have 3x squared minus 9x minus 1 equals 0. Now it is set equal to 0. All 5 problems are good to go. So we can go in Desmos and we're going to graph each one and see where it crosses the x-axis. So off we go. And just a note before I go in Desmos, if you were to subtract 3x squared from both sides, it would have gave you the same answer. I'm just setting you up for some things that are coming in the next few days. So I just moved everything over to one side and we're going to graph it in Desmos. So I'm going to try to do my little split screen again so we can see everything. So this is problem number 1 that I already have here. So x squared plus 8x squared plus 8x plus 12. We're looking for where it crosses the x-axis. So Desmos will give me those points. I see a point here and I see a point here. So for number 1, it crosses at negative 6, 0, and it crosses at 2, negative 2, 0. So my two answers, x equals negative 6, x equals negative 2. Ta-da! And just like that, we have solved this equation by graphing. So now I'm going back and I'm going to graph each one so we can get our answers. So we graphed it. We got x equals negative 6 and x equals negative 2. It's where it crosses the x-axis. All right, let's get rid of this one. We're on number 2. So let me highlight number 2 here. So number 2. Now I could change the window so that I can see the whole parabola. So I know that it's going up. It kind of cut off at the top there and then it comes back down. But I'm not concerned about the whole parabola. I really don't care. I only need to see the part where it crosses the x-axis. So I can hover over. You use your pointer and hover over and find the 2 points where it crosses. So it crosses at negative 3, 0. And it crosses at 7, 0. So our two solutions, x equals negative 3, x equals 7. And ta-da, we have just solved that equation. So we just solved this equation. We graphed it, make sure it's moved over to one side, and we got our two solutions. All right, moving on. Number 3. So let me get rid of this one. So number 3, we type in Desmos x squared minus 8x plus 16. Use your pointer key to hover over the x-axis where it's going to pop up. And there we have it. So we have 1 point. So this is 4, 0. So our solution is x equals 4. And we actually call this a double root. So if you see that phrase, it's actually called a double root. Now, I do want to draw our attention back up to our notes that we wrote at the beginning there. It says a quadratic equation can have 0, one or two real solutions. So notice that this is an example. The first two problems that we did crossed the x-axis twice. This one only crossed once. So it can cross 0 times, it can cross once, or it can cross twice. All right, number 4. Number 4, you'll type in Desmos negative 2x squared minus 5x plus 1. You'll hover over, get your points. Ta-da, and ta-da. And it's okay to get decimals. So our first point is negative 2.686. And then my other point is 0.186. So our two solutions, x equals negative 2.686, and x equals this. All right. Now, I am just writing the ordered pairs out, so hopefully you'll see a pattern that all of your x-intercepts are a number and 0, a number and 0, a number and 0, etc. So that's one reason why I'm writing out the two separate points. Another reason I'm writing out the two separate points is so that you know that they are separate. So I wouldn't want you to put these two numbers together and think that they are one ordered pair, because they're not. They are two separate ordered pairs. And the last one, number 5, we'll check out our answer for number 5. So we'll type in 3x squared minus 9x minus 1, which I already have. We'll go find our roots, which are our solutions, x-intercepts, all those good things. So my two ordered pairs, I got this one. And my other ordered pair is the following. So just copy and write what I got from Desmos. So our two answers are the x coordinates. So your two answers are the x coordinates. So those are our two answers. So now we've gone through and we solved equations by graphing. We haven't done one yet, but I do want to show you one that doesn't cross at all. So problem number 3 was an example of one solution. All the other ones were an example of two solutions. Let me find one, make one up that is going to be right, no solution. So say I had something like this. This would be an example. So this parabola over here on the right side of your screen there, this would be an example of a parabola that does not cross. So you would say that there were 0 real solutions. So there's an imaginary solution that we'll get to in a few days, but this one does not cross the x-axis. So our answer to this one in the green, you would say no real solution. So 0 real solutions. And that is graphing. So now we know how to graph and solve a quadratic equation by graphing.